Hello everyone. Now today we are going to discuss the problem on Stoke's theorem. Now this is the second problem on Stoke's theorem. Now look at the problem. Verify Stoke's theorem for the vector function f equal to y square I plus yj minus zxk, and s is the upper half of the sphere, x square plus y square plus z square equal to a square, and z greater than or equal to 0. Now before going to look at the Stokes theorem and its verification, first look at the given surface, right? Now the surface here given upper half of the sphere x square plus y square plus z square equal to a square, and z equal to 0. Okay, sphere shape, like upper half of the sphere like a hemisphere, like sphere is like a ball. When you cut it exactly half of that is like a hemisphere. Now the given shape also like hemisphere. Now the hemisphere height along we have z greater than or equal to 0, nothing but the positive z we have, there is no negative z. Okay, the positive z we have, there is no negative z. Negative z is they won't given, right? Now is the lower half of the sphere, upper half of the sphere we have like z greater than 0. That's why, that is the reason we have height we have along z. Now the base, the open upper half, that half we have open it on xy plane. Okay, over that open surface we need to verify Stokes theorem. Now the Stokes theorem is integral over c f into dr equal to integral over s curl f dot n ds. Now look at the LHS first. Integral over c f into dr f dot dr is like a r is xi plus yj plus zk position vector. Now dr is dxi plus dyj plus dzk. Now apply the dot product, y square into dx plus y into dy minus zx into dz minus zx dz. Now the open surface on xy plane is like a circle equation, right? Now the open surface we have curve circle. Now circle we have on xy plane, x square plus y square equal to a square. Now what is the z value on xy plane? Simply 0. Now dz is 0. Now apply dz 0. Now this quantity is 0. Now this we need to integrate it for over a c or a curve integral, right? Now this integral, now try to convert these total y and x terms into the only one variable by using this. Okay, now simply you can substitute for y square equal to a square minus x square, and y we have like root of a square minus x square. When I apply it, difficulty do the integration. Now it's a circle equation, right? Better to switch over to the polar coordinates. Now that is the reason I put for x equal to a cos theta and y equal to a sin theta. Now for this circle, now theta varies from 0 to 2 pi. For the making a circle on xy plane, now theta is varies from 0 to 2 pi. Now integral over c f into dr equal to integral 0 to 2 pi. Now y square is a square sin square theta into dx is a into cos theta derivative minus sin theta d theta plus y is a sin theta into dy a into sin theta derivative is cos theta d theta. Now this minus I will write it here, a square into a cube. Now theta is 0 to 2 pi, sin square into sin cube theta d theta plus a into a square. Now this integration I split to the two terms, a square into integral 0 to 2 pi sin into cos theta d theta. To the integration of sin cube theta, I simply use this formula, sin theta equal 3 sin theta plus 4 sin cube theta. In that I pick up for sin cube theta equal to sin 3 theta minus 3 sin theta into 1 by 4. Now 1 by 4 into sin 3 theta minus 3 sin theta. Now this formula apply here. Now I will do it for here into 2 and divide 2. Now 2 sin theta cos theta can be written as sin 2 theta formula. Okay, now these two formula apply here. Now integral over f into dr is minus a cube. Now this formula 1 by 4 into sin theta minus 3 sin theta d theta plus a square by 2 into now 0 to 2 pi sin 2 theta d theta. Now this integration a cube by 4 constant sin theta integration minus cos theta by 3 plus minus 3 into sin theta integration minus cos into minus become plus 3 cos theta. The limits are 0 to 2 pi plus a square by 2 into sin 2 theta integration minus cos theta by 2 0 to 2 pi. Now apply the limits. Now upper limit minus lower limit. Upper limit applied here. Cos 3 into 2 pi. Cos 6 pi. Cos 6 pi is 1. Okay. The formula we have cos n pi equal to minus 1 to the power of n. Right. Now here cos 6 pi minus 1 to the power of 6. Nothing but minus 1 to the power of even number is positive 1. That is a positive 1 into negative is minus 1 by 3. Now plus cos 2 pi. Cos 2 pi is minus 1 to the power of 2 minus 1 to 1 again is a plus 1 into 3 is 3 minus lower limit 0. Cos 0 is 1 into minus 1 by 3 plus again cos 0 is 1 into 3 is 3. Okay, upper limit minus lower limit. But second term plus a square by 2 into minus cos 2 into 2 pi cos 4 pi. Cos 4 pi again plus 1 into negative here negative 1, right, minus 1 by 2 minus lower limit 0. Cos 0 is 1 into minus 1 is minus 1 by 2. Now minus 1 by 3 minus a cube by 3 into minus 1 by 3 plus 3 minus into minus plus 1 by 3 minus into plus minus 3 plus a square by 2 into minus 1 by 2 plus 1 by 2. Okay. Now minus 1 by 3 plus 1 by 3 plus 3 minus 3 here minus 1 by 2 plus 1 by 2 will cancel. We have 0. The LHS we have 0. Now next to go for find the value of RHS. Okay. Now RHS. Now before going to evaluate this RHS, first I will find for curl F. Now curl F is IJK dou by dou x dou by dou by dou by dou z y square and y zx. Now I into zx with respect to y is 0, y with respect to z is 0, 0 minus j into now with respect to x here minus z. Now with respect to z for y square is 0 plus k into with respect to y with respect to x is 0 minus y square with respect to y is 2y. Okay. Now minus into minus plus z is a plus into minus is minus 2yk. Now is a curl F. Now next find for n bar. Now our open surface on xy plane and the curve we have positive z, right? Now we need to find out n is a outward normal, unit outward normal. Now when you put for normal for z along positive z is inside the normal, not for outside. For this open surface, when you pick up that k is a normal, the k is inward normal, not outward. The outward normal is opposite direction of positive z, that is minus k. N is minus k. N is minus k. Now apply an integration, double integral over s curl f dot n dot ds. Now curl f is zj minus 2yk dot minus k dx dy. Now here minus into minus plus 2y dx dy. Now to integrate over that circle, now pick up the limits. For the circle we have an xy plane. Now pick up the limits. I take for vertical strip. Now y varies from, now is a circle we have x square plus y square equal to a square. Now y equal to minus root of a square minus x square to root plus root of a square minus x square. Now x varies from negative a to positive a. Okay, now these limits I'll put it here. Okay, x limits and y limits. 2y dx dy. Now first integrate with respect to y. next with respect to x. Okay, why we have variable limit? That is the reason first we integrate with respect to y. Now 2 into y integration y square by 2. 2 cancel. Now limits applied, upper limit applied, y square. Now square root cancel, we have a square minus x square minus. Now this square, now negative square is positive, root, square root, whole square becomes square under square root cancel, then a square minus x square. Now a square minus x square minus a square minus x square will cancel, right? Now these two are cancel, same quantity having different sign, cancel, we have 0. 0 of integrand is 0. Now LHS we have 0, RHS we have 0. Simply we verify the Stokes theorem. Now the similarly we have the other problem, verify Stokes theorem for f equal to x y 2x minus y into I minus yz square j minus y square zk, where s is upper half of the sphere, x square plus y square plus z square equal to 1. The similar curve we have as we discussed with the previous one, second one, third one also same. Okay. Now this problem, try it, then we can get the solution. Okay. Thank you. Now next class I am going to introduce a volume integration and Gauss theorem, Gauss divergence theorem. Thank you.